Video transcoder change video format to another, squeezing compatibility into every pixel. But video processing units, VPUs, make our videos smarter, tweaking pixels to perfection. Let's find out which one is more crucial for which video needs. Hey Jan, why should I care about video transcoders and VPUs? Can't I just stick to my old school software based methods?
You can stick to your old software-based methods for some types of applications. If you're encoding H.264 for VOD, software can work acceptably well. On the other hand, if you go into the live realm, software quickly becomes inefficient from both a cost perspective, cost per stream, because you need many more servers to produce the same number of streams as you would do with a single ASIC, and also from a power per stream, because all those servers take a lot of electricity. So, H.264 VOD is fine. When you move to live, that is another increase in complexity. When you go to more modern codecs like HEVC and AV1, you're increasing the encoding complexity by a factor of between 5 and 10x. And with software, that slows you down. And with hardware, since the operation is done in hardware, you get the same output, whether it's H.264, HEVC, or AV1. We recently did some tests with a server product that we're launching that's got 10 quadras in it. And what we found was that in some configurations, it could produce the same output as 28 standalone servers. So if you're producing HEVC encoding ladders using 4K output, one quadra ASIC-based server unit can outproduce 28 single CPUs. So that's a tremendous increase in savings when it comes to both CapEx and OpEx. And that's what we're seeing as things get more complex, the need for VPUs and transcoders becomes more apparent and more obvious.
Sounds like as operations get more complex, CPUs and GPUs make less sense. Have we seen this before?
Yeah, that's right. I mean, and we have seen it before. I mean, if you look at the history of Bitcoin mining, for example, that started out with CPUs, and then it moved into GPUs because they were more efficient, which means more output for the same electricity, the same cost. And now it's almost exclusively done with ASICs because they deliver much higher efficiency at much lower cost per output and power per output. We're seeing the same thing with AI. AI was originally done with general purpose CPUs, and now that's moving exclusively to GPU. And we're seeing that, finally in the video realm, as I described. I mean, as you go from VOD H.264 to VOD Live to HEVC, HEVC Live, AV1 Live, you're increasing the complexity, and you really can't do it economically in software, either from a cost per stream or a power per stream perspective.
Okay, you've convinced me that video processing efficiency matters, but how do transcoders and VPUs differ in terms of performance?
There are no hard definitions of transcoders or VPUs. Typically, what you see with a VPU is that it's another generation of transcoding ASIC. And of course, NETINT is the only company with two generations of encoding ASICs that are on the market. And what we saw with the Quadra, which is based on the G5, as compared to the T408, which is based on the G4, is that it produces 4x the output, plus gives you artificial intelligence, gives you the AV1 codec, and gives you onboard scaling and overlay. So it's a lot more capable in terms of what it can do, and it's also 4x the output.
What are the real life applications where transcoders outshine VPUs and vice versa? Let's talk practicality.
So practicality, I mean, again, we're the only company that's got both a transcoder and a VPU. And we see the T408 still doing well in some applications that are very cost-centric and never want to go beyond H.264 or HEVC. On the other hand, if you're looking ahead, if you really want to be able to scale most effectively, and of course, if you want to introduce the AV1 codec, then you need to move to the Quadra VPU.
Can you share any secret tips and tricks for maximizing the efficiency of transcoders and VPUs?
I mean, that's the thing about hardware. There are no tips and tricks. It simply works. So with software, you really have to worry about throughput. You have to mess with presets. You have to mess with other parameters that increase the throughput through the system, or manage the complexity of the operation that's going on. With ASICs, it just works, and you can produce pretty much the same output irrespective of the codec that you're delivering in. And you can operate at between 95 and 90% capacity because you're never going to outstrip the capabilities of the board. With software, you typically have to work in the maybe the 70-80% range, because if you spike in terms of complexity, you may crash the entire system. With ASICs, you don't have to worry about that, and really they just work. You don't have to worry about them in the same way that you worry about software.
Hold on a second, there must be something. What about hidden cost associated with using transcoder or VPUs? Don't keep me in the dark.
There really aren't any. As I've talked about, they simply work. They're application specific. They were built purpose built for transcoding, and that's all they do. So typically, you just install them, you turn them on, and they work until you turn them off.